So here's the homework for tonight. We're going to be looking at some word problems. Those word problems involve similar figures. Please do not sit and copy these problems down. That would take way too long. Don't want you to do that. Instead, just sort of write down what I write. So write down the writing that you're about to see. So it says an architect is building a model of a tennis court for a new client. On the model, the court is 6 inches wide by 13 long. So what I would suggest at this point is you take just a few seconds to... When I see it talking about like a shape, in this case a tennis court, I want to draw that shape. So go ahead and draw that. Now what shape would a tennis court be? Yeah, a tennis court's going to be like a sort of a rectangle shape. So I'm going to use this so that I draw a really good rectangle. You could just freehand it as well. So there's my original tennis court, and it says it is 6 inches wide by 13 long. So let's see, where would I put the 6? The long side or short side? Short side makes more sense, and then 13. All right, and we know they're inches for both. Oops. Okay. Then it says an official court. So this is the model size. The official court is bigger. So what I'm going to do is I'm going to take this model. I'm just going to copy it. Only it needs to be bigger. So notice it's similar. I just made it larger. So these are similar figures, meaning they have the same shape. Now this is 36 feet wide, so this is the width. Let's see, width, 6 was the width, so the 36 needs to go here. You see how I did that?
Wait, hold on.
It says 6 inches wide, so the 6 went, and since it's 36 feet wide, I put it where I put the 6. Does that make sense? Yes, sir.
Why wouldn't wide be like on the bottom, since like it's the wide and like tall, or like the long side would be on the left or right?
Good question. So in general, the short side is what we call the width, and the long side's the length. But on this one in particular, you can tell because there's a shorter side in 6. So I put the 6 on the side that looks shorter.
Oh, okay.
That's a good question, though. I'm going to put an L here because I want to know the length. So these are similar figures. Similar figures are in proportion. So let's make a proportion to solve this. And you're going to see that over and over again on this sheet. I'm going to start with L. What corresponds over here to the L? 13. That looks like a Z, but it's an L. Sorry, it's an L. 13. So I'm going to put a 13. Now it looks like a B. I don't know. Let's fix that. It's not. Oh, never mind. L. All right. L over 13. And then let's see, since I did the big triangle over the small one, so I need to go back to the big triangle and get this. What's the other side? I've been saying triangle, haven't I? Technically, it's a rectangle. I apologize for that. It's a rectangle. All right, and then over, what would correspond? 6. So there's your proportion. Any questions? Now to find the length, you're just going to cross multiply or solve the proportion different way. 6 times L is 6L. 13 times 36 is?
468.
468? Seems good to me. In this case, I'm going to go ahead and use an L like that, just so it doesn't look like a 1. And then we'll divide both sides by 6. What is it? 78. And the big tennis court was in feet, so I'm going to put 78 feet. And then we're done. Any questions about number 1? Yes, sir?
I had a question, but like, I don't think, like, it has to do with the same, but like...
All right, so this is similar to a couple that we did in class today, talking about shadows. I'm going to go ahead and draw it out. You're not going to have to draw out all these, but go ahead and draw this with me, please, so that you have something to look at. And then eventually you should be able to do them without drawing them. I just want to illustrate this one more time. So yeah, Mr. Hemley. I'm going to go ahead and draw Mr. Hemley. There's Mr. Hemley. Call him Mr. H. Mr. H. So he's sitting next to this monument, this Illinois Centennial Monument. So let me go ahead and draw the monument too. So there's our monument. So Mr. Henley casts a shadow. How long is his shadow? 18 feet. Any questions so far? All I'm doing is drawing out what the problem says so I have something to look at. Now the shadow of the monument is 204 feet. Now it really should be longer than that line that I drew, but we're going to stop it there because I'm out of room and it doesn't make a difference. So I've labeled this information so far. If Mr. Henley is 6 foot tall, so let's see, it gave me Mr. Henley, that's here. He's 6 feet tall. It wants to know how tall is the monument. So it wants us to find this out. So what can I put here? M, H, X. You put M for monument, H for height, X because you don't know anything better to put. Anything's fine. So just remember from class, just as a quick review, what shape would this make? Yeah, if you attach the top of Mr. Henley's head to the end of the shadow, back and up, that's a triangle. What shape would you make here? Same shape. And my lines aren't perfect, and I didn't draw to scale, but these would be similar triangles. So this is a similar triangle problem. In this case, we have 18 by 6 and 204 by M, because we don't know. What can you use to solve similar triangle problems? Similar shape problems? Yeah, use a proportion. That's what we're going to do. And in this case, we're just an easy way to remember it, because you don't want to have to draw this every time. This is just to show you why we do what we do. But an easy way to remember these kinds of problems when you're talking about shadow problems to measure things is you do height over shadow equals height over shadow. There are other ways to do it. I'm just showing you this way so that you have a consistent way to set it up every time. So what I'll do is I'll make a proportion of 6 is his height. What is his shadow? 18 equals, what's the building's height?
13.
We said M, didn't we?
Yeah.
And what's the building's shadow?
204.
204. Now you can just cross multiply. So 18 times M is 18M.
1,224.
6 times 204 is what?
1,224.
And then what do we get when we divide both sides by 18? 68. And we're talking about what, feet throughout? Yeah, so 68. I don't know if I have room for it, but it should be 68 feet. Any questions? That's called indirect measurement because we measured the monument without actually measuring the monument. We used other measurements to find it. Yes, sir.
Does it matter how long it has to be? Like the shadow, can you do like any line?
Your drawing's just something to look at to help you, so your drawing doesn't have to be perfect.
Okay,
That's what you're asking.
Okay, I draw a certain,
No, you should be good without it. So let's look at this. The dining room at Monticello, Thomas Jefferson's home in Virginia, is 216 inches by 222 inches. So what should I do right now?
make the house like dining room.
Should make a dining room. And we're just going to assume it's a rectangle since they only gave us 2 dimensions. So go ahead and draw a big rectangle for your dining room. If I could get every student that I teach to just draw shapes and draw visual representations every time they saw a problem that talked about shapes, we would be doing so much better than we are now. Like, we're not doing bad now, but this helps. This is something I do whenever I work problems. All right, so it's 216 inches by 222. So this is the short side. So let's do, and this isn't a good representation of what you were asking about, Caden. If you look here, like, is this much different, 216, 222?
No.
No, so it's almost a square. So my rectangle clearly is not the right size. But does it matter?
Oh.
No, this is just a picture to help. Okay. Of the following, which size rug would be similar in shape? So we want to know, all right, if I took a rug, let me just take this. If I took this and made a similar shape so that the rug just sits in the middle of the room and is similar to the room like this, what could the rug be? Now, let's rule out some answers. Are these 2 dimensions the same?
No.
So could the rug be the same 2 dimensions?
No.
Not if it's similar. So what answer can I rule out right now? Actually, that is, I misread that. I thought that was a 74.
Yeah.
So none of the answers rule out yet. My bad. So let's try a couple different things. Let's try 72, 74, and see if this works. I hope you see how the picture sort of helps. Maybe it doesn't. I don't know. Helps me. If they're similar, the sides will be in, they'll be in proportion. So I'm going to do 72. What corresponds to 72? 216. The picture helps you really see what corresponds here. Equals 74. What corresponds? Now cross multiply to see if these are similar. So 216 times 74, someone said was what was it again? 2,000?
15,984.
15,984?
And then 72 times 222 would be the same thing as 2,984.
Did we get the same thing for both?
Yes.
Oh,
No.
are they? You got the same thing for both?
What?
Yes. Yes.
Yeah.
So they're similar. That means, because that's proportional, that means that it looks like F's the answer, and then we could check the other ones to see, but we're already over 10 minutes, so we'll just leave it at that. And if anyone who's watching this video thinks it's different after checking any of the other ones, let me know. Maybe we need to look at it again. Just usually the first one doesn't ever work when we do these. So it looks like that's it, though, based on what we got when we cross-multiplied. So that is similar, so it would be F. If you got two different numbers, then it would not be similar. So I'm assuming that these would be different numbers. Any questions? I think I'm fine stopping there. Let's just set this one up. Remember, when you're doing shadow problems, they're similar triangles, so you can make a proportion, and we just do height over shadow, height over shadow. So in this case, the height of the sign is 9. What's the shadow of the sign?
12 foot.
12. The height of the lamppost, we don't know, so I'm put L. What's the,
24.
so this proportion would give you the answer to this. So the one thing I want you to do on your own is just finish this. You know how to do it and find the answer to that. Any questions? All right, we're done.